Good morning. Today we'll be talking about the topic of sound. Now we need to understand that firstly, sound is a mechanical wave, unlike light, which was an electromagnetic wave. So its main principal property is that sound can only travel in the presence of a medium. It cannot travel in the vacuum or in space. So it always needs a medium to travel, and further, the speed of sound is greater in three mediums. The speed of sound in solids is greater than the speed of sound in liquids than the speed of sound in gases. Why? Because we need to first understand that how sound is propagated. Sound is produced by the vibration of atoms. Now, whenever atoms collide with each other, there are multiple collisions. And as a result of the collisions, there are high pressure and low pressure regions which are formed. These high pressure and low pressure regions are alternately referred to as compressions and rarefactions. Now, this thing has been summarized over here. So basically, energy is being transmitted when the molecules of sound or the molecules of a substance collide. And examples of substances which produce sound include guitars, drums, and even our own mouth by the help of the vocal cord. Now, in this video, you will be able to see that how there is a ripple effect being produced when the tuning fork collides with each other. There is a ripple effect being produced, and whenever they talk about the wavelength of sound, you need to remember that the wavelength is the distance from one sound wave to another. It is represented by a lambda. So they've talked in detail about how this is how a tuning fork collides, and you can see that there over there are some darker lines and some lighter lines. The darker lines I talked to you about previously are the compressions, and the lighter regions are the rarefactions. Now this is a formula by which we will be able to calculate the frequency and the distance or the wavelength of sound, which is V equals to F lambda, where V is the speed of sound. In air, the speed of sound is typically 333 meters per second. And in multiple scenarios, you'll be either given the frequency or the wavelength, and you'll be asked to calculate either the frequency or the wavelength. Now, a very interesting the relationship you need to know is that whenever two things are multiplied with each other, it means that they are inversely proportional to each other. So the frequency and wavelength of a sound wave are always inversely proportional to each other. So the greater the frequency of a sound, the lesser is its wavelength. Now we come to the range of audible frequencies. Now human ear can only hear between 20 to 20,000 hertz. Now those basically a dog whistle, as you would have heard, is basically above 20,000 hertz, and only certain animals such as dogs or cats can hear them. Similarly, such very low frequency sounds below 20 hertz can also not be heard by humans. Now, those sound waves which are above 20,000 hertz are basically ultrasound waves, and we'll be covering the applications of the ultrasounds in detail as well. So, how is a sound wave being generated? A sound wave is generated when an object vibrates through the air. Now, I'll be coming to the next topic. We talk about the loudness and the pitch of the sound. So now what is the loudness? The loudness of a sound wave is basically determined in decibels. And how loud a sound wave is, you say that a sound wave is 10 decibels or a sound wave is 20 decibels. So the greater the number of decibels, the greater is the sound wave. And how do we determine how loud a sound wave is? We measure its amplitude. So the greater the amplitude of sound wave is, the greater is its loudness. Over here in these graphs, you can see that the vertical height is referred to as the amplitude. And in these two boxes, box number one has the greater amplitude, thus it has greater loudness. Now you need to carefully understand that the thing audible decibels and amplitude aren't the same. Sometimes it happens that the amplitude doubles, but the number of decimals does not necessarily have to double as much. Now here is the frequency. You can see I told you that the pitch is that refers to the frequency of waves. Over here there's a single large wave, but so that has a less frequency. However, over here there are four peaks, in other words. So the frequency of box number two is much greater. Now, what is the pitch? A pitch is the musical quality or the timbre of a sound. Every sound produced has a different pitch. For example, uh, in choirs or in opera singers, they have a unique pitch which enables them to sing so loudly that everyone in the hall can hear them. So there are high pitched, so basically instruments and low pitched instruments. High pitched instruments are the drum and the bass, which enable the noise to basically spread easily, whereas those such as low pitch are the low frequency sounds. So they talk about the concert. In the concert, the pitch of the sound is extremely high and the timbre is high as well. So there is the instruments which are being used are high bass. High bass means that they are perceived even louder as their amplitude which they are on in already. Now the next topic I'll be covering is sound and echo. So now what is an echo? You need to understand that an echo is produced. For example, you stand in a long hallway and then you scream something or you say a word. So several times you would have experienced this in your life that your own voice is being repeated after several seconds. Why does this occur? This happens because there is a long hallway and nothing to obstruct the sound wave. The sound wave travels through the entire hallway, and once it strikes the wall at the other end of the hallway, it strikes it back and is reflected back. So the distance is basically it covers is the twice the amount that it normally needs to do. So over here in this text, they've talked about the how the speed of sound is higher in liquids and solids than air. Why? The reason is because we all know that in solids the molecules are more tightly packed than liquids, and vice versa for liquids than for air. So the obviously the more tightly packed the molecules are, the more strongly they will be able to collide with each other, and the higher the frequency of sound wave. So now as if we talk about an echo. I know the normally we know that the speed is calculated by the formula speed equals to distance over time. However, as I talk to you that in the case of echo, the distance is twice. So the formula can be conveniently changed into S equals to 2D over T because the distance in this particular occasion is twice the distance. Now, there are several other factors as well which can affect the sound wave. The major factor is temperature. You need to know that the greater the temperature is in an environment, the greater the speed of sound because the molecules of an atom collide more and more with each other and more vigorously with more energy. Humidity has a very minor effect, however, it decreases the speed of sound. This is how diagrammatically they've explained how, for example, you clap and the sound wave hits the wall and it is reflected back into the air. So this is an experiment in which you are basically have to do in order to make an echo. Now you need to understand that the speed of sound increases by 0.6 meters per second per degree Celsius increase in temperature. This value you have to remember. And humidity, I've talked about previously as well that this affects sound very minorly. Now I come to the last part of the topic, which is ultrasound. Ultrasound waves are those sound frequencies which are above 20,000 hertz and not audible to the normal human ear. However, they have numerous medical applications. Here you can see that in prenatal testing, doctors are often use ultrasound to basically view the fetus in the womb and look for any structural abnormalities or how the fetus is growing. Apart from medical, the other applications can be to clean street lights because normally the streetlights can't be cleaned as cleanly as it can be by the ultrasound waves because the extremely intricate portions of the lighting unit can be easily cleaned by this process without having any damage. And similarly, other uses are also listed in jewelry and wheeled plastics. However, the ones we'll be more talking about will be prenatal scanning as I talk to you and diagnostic imaging in which of majorly ultrasounds are carried out in the urinary bladder or to find out the stones in the bladder or in the gallstones or to even treat kidney stones. What happens is that due to enhancement in modern technology, instead of taking the stones out and doing a rigorous surgery by the use of ultrasound, you can simply break the large pieces of stone into smaller pieces of stone so that They can be easily passed through the urine by the help of diuretics. Diuretics are those substances which increase the urinary outflow of the human body. I hope you like the video. Please like it. Thank you.